Hello, Algebra 2, and welcome to Chapter 7. Today we're going to talk about solving absolute value equations and inequalities. So first of all, just remembering about absolute values. The definition is the absolute value of a number is the distance it is from 0 on a number line. And then in that case, distance has to always be positive. You can't say I traveled a negative distance. If you traveled a distance, it had to be positive. So here we have, this would be a piecewise notation that we'll talk about later, but just kind of breaks down the absolute value of x is going to just be x if x was positive to start with. It's going to be 0 if x was 0 to start with, or it's going to be negative if x was negative to, it's going to, sorry, let me say that again. It's going to be the opposite of x if x was negative to start with. So as an example, so if x is 3 to start with, then the absolute value of 3 is just 3. The absolute value of 0 is 0. The absolute value of negative 3 is 3, and that would be the opposite of what x started as, and that's what that one means there. So how do we solve an absolute value equation? And I'm going to kind of walk you through this as an example. So let's say we have the absolute value of 3x plus 5 is equal to 12. Okay. So what we just talked about as far as what the absolute value can be, I'm actually going to erase this part right now and ask you what could be in here that the absolute value of it equals 12. Well, what could be in here either can be 12, because the absolute value of 12 is 12, or it could be negative 12. So this part inside has to either equal 12 or negative 12 for its absolute value to be 12. So how to solve these then is that you're going to set up two cases, and you take what's inside that absolute value, and essentially what we do is we set up a positive case and we set up a negative case. And then you're going to solve them both. So these are going to have two answers. And they have two answers because there are two different cases in which case you get that absolute value. And I'm going through this kind of quick, but I'm sure you can do this part. Okay, the nice thing too is you can check these. You should be able to put in both of those numbers and they should both give you an absolute value of 12. So let's look at another example here real quick. So this inside part has to either be equal to 15 or it has to equal negative 15 for when you take the absolute values that now you can't see because I covered them up. When you take the absolute value, you get 15. So we're going to make the inside part equal 15 and the inside part equal negative 15. And I would like for you to solve those. Okay? And then that is going to be your quiz question. So next we're going to talk about solving absolute value inequalities. And it's quite the same. So you're going to have the absolute value of something. But this time you could have it less than something else, or it could be greater than something else. And so depending on if it's less than or greater than is to actually if it turns out to be an and or an or. So let's look at less than 5. Which numbers for x have an absolute value less than 5? So like 4 does, 3 does, 2 does, 1. These all have absolute values less than 5, right? And how far can I go? If I go to negative 5, does it have an absolute value less than 5? It doesn't. Now we need to go to like negative 4.9. But it's these numbers between negative 5 and 5, which makes this be an and statement. So x has to be less than 5 and x has to be greater than negative 5. So if you start out with a less than inequality, it's going to turn into an and compound inequality. Similarly, let's look at greater than. So let's say it was greater than 5. So which numbers have an absolute value greater than 5? Well, 6 does, 7, 8. These all have absolute values greater than 5. Also, what about negative 6? Is its absolute value greater than 5? Negative 7, negative 8. Do they all have absolute values that are greater than 5? So this then is an or. So either x has to be greater than 5 or x is less than negative 5. So if you start out with a greater than, it's going to be an or statement. So we have 2 to solve here. So first out to note, so this is a less than, so it's going to turn out to be an and. And really what we're going to do is we're going to solve it exactly like we solved our example with an equation. So there is my positive case, and then my negative case, though, I'm going to say it has to be greater than or equal to negative 21. And we're going to solve them both. And let me point out, too, you could just say it's less than or equal to 21 and it's greater than or equal. You could do it like that and then just solve it all at once, and that would be fine. I'm going to solve it as 2 separate ones. So we're going to get 4x is less than or equal to 30. Divide by 4, x is less than or equal to 15 halves. And this is 4x is greater than or equal to negative 12. X is greater than or equal to negative 3. And since it's an and, you need to come together and write it as 1. And remember, you always go least to greatest there. So there is your and answer for the first one. The second one starts out as a greater than, so it's going to be an or. And to solve an or, same thing, there's my positive case, there's my negative case. Notice on both negative cases you flipped your inequality. Solve them both. And in this case, you're just going to put an or between your answers. So there's the first one, or, I don't know why I didn't pick ones that had nice answers here, but works, x is less than negative 16/3. There is your or answer. Remember, or answers always have to have the word or, and answers need to be written as one. All right, I know that was a quick review. Let me know if you have questions, and have a good day.